In this demonstration, we'll explore how Ansys EMC Plus enables platform-level electromagnetic emission analysis for consumer electronics, helping engineers predict and visualize electromagnetic field distribution early in the design process. Our example focuses on a laptop platform where we evaluate electromagnetic emissions generated by an internal antenna and study how these emissions propagate throughout the enclosure. The workflow begins by importing the product geometry into Ansys Discovery. The CAD model is imported using the standard geometry import function, allowing engineers to quickly prepare existing product designs for electromagnetic simulation. Once the geometry is available, the next step is to define the simulation domain. The simulation domain represents the computational region used by the finite difference time domain, or FDTD, solver. It is important to ensure that the entire product is fully enclosed within this domain, as it determines the lattice mesh and provides the space required for accurate electromagnetic field calculation. With the simulation domain established, we move on to material definition. In this example, the laptop enclosure is assumed to be made of PVC plastic. Accurate material properties are essential because they directly influence how electromagnetic waves propagate, reflect, and interact with the surrounding structure. After defining the dielectric properties, the material is assigned to the complete enclosure model. Next, we introduce the electromagnetic source. Rather than modeling the antenna again, the antenna has already been simulated separately in Ansys HFSS. The resulting near-field data is exported and imported into Ansys EMC Plus as a near-field source. This approach allows engineers to combine highly accurate component-level electromagnetic simulations with full platform-level analysis, creating a seamless multi-physics workflow across Ansys solutions. The imported antenna source is positioned inside the laptop exactly where it would exist in the physical product. To visualize electromagnetic behavior during the simulation, we create an animation probe. A probe plane is first defined across the region of interest, and an animation probe is assigned to this plane. For this demonstration, the probe is configured to display the normal electric field, allowing us to observe how electromagnetic energy propagates throughout the laptop enclosure. In addition to electric fields, Ansys EMC Plus also supports visualization of other electromagnetic quantities, including magnetic fields, current density, air conductivity, spatial charge, and electric currents, providing engineers with multiple perspectives for design analysis. Once the model setup is complete, the next step is mesh generation. The geometry is automatically discretized into computational mesh elements, creating the numerical model required by the FDTD solver. An appropriately generated mesh ensures accurate prediction of electromagnetic behavior while maintaining computational efficiency. With the mesh complete, the simulation is executed. After the solver finishes, we move to the results section to generate the animation. For improved visualization, the display scale is switched from the default automatic setting to a logarithmic scale, making both strong and weak electromagnetic fields easier to interpret. The animation clearly illustrates how electromagnetic emissions generated by the antenna propagate throughout the entire laptop platform. This enables engineers to identify high field regions, evaluate potential electromagnetic interference, verify shielding effectiveness, and better understand platform-level electromagnetic performance long before a physical prototype is available. By integrating component-level simulations from Ansys HFSS with full system electromagnetic analysis in Ansys EMC Plus, engineering teams can accelerate design validation, reduce costly redesigns, improve EMC compliance, and deliver more reliable electronic products. Thank you for watching.